So as I told you, we have done this in another section for the and now we're going to do it in the classroom. So in the classroom, we have to place the mechanical equipment. This one, this AC air conditioner. And well, let's place it somewhere like this, and then let's try to, is it in the right place? Well, it has to be on level 15, and then we need to find the right elevation, because on level 15 now it's on the floor of level 15, but we have to move it up to the ceiling. So what's the elevation? Let's try 12. 12 is probably too low. I had to move it indoors. Okay, yeah, so this is the slab. I can move it up, maybe 13 or even 14. 14 is too much, so I will make it 13 and 10 inches. Okay, so it's remember that we use this element to hang it from the ceiling. Okay, so that's the right height, and now we have to place it in the right position. So if these are the classrooms, I should place it, let's say here. Here. Okay, so I'm going to try to do something like this. You remember, well, look at this. And we have the supply duct here. We have the return duct there. And we have two grills. This is the supply close to the supply duct. And this is a return close to the return duct. So if this is the supply in this classroom, this is the supply grill or diffuser. This is the return diffuser. So I'm going to, okay, this is out. Out means supply, and in means return. So I have to relate it.
I don't have the air conditioner unit, and I downloaded other ones.
Okay. So in is return, and out is supply. So what I'm going to do is to copy this supply diffuser here. I could insert one from scratch, but I think it's better because we have the right position and the right and the right height. And then I'm going to copy another return one here. I'm going to center because it will look better if we center this. Okay, so let's see what we have done. We have the split indoor unit here, and this is the supply diffuser, and this is the return diffuser. And now we have to connect both here and the other one there. So as you can see, this element goes well because if we create a duct here, if we start drawing a duct, so that element goes well with this kind of diffusers, this long diffuser, okay? So if you want to do it, go ahead and find a diffuser like this. But if you don't, we can select here a round pipe. We don't need this pipe here. So change the diameter to 10. Okay. And now we can connect with a flex duct here. Okay. And now we can do the same with this one. We can draw a duct, select a round one, change the diameter and connect the flex tab. Okay, so this is it. We have one here, and now we need the same in each classroom. But each classroom, it's like this. We need a supply duct from the air handling unit. We need a return duct from the air handling unit. And then we need a split unit with supply and return. Okay, so we are doing the same layout that we have in this classroom. Supply and return ducts, supply and return diffusers, because they are connected to a split unit that it's in this hosting. So once we have this, you can copy everything, the split unit and all the ducts to different classrooms. We have 1, 2, and 3. Okay, so we have this, and are we done with it? No, not yet, because now we have to connect the each split unit to a heat pump that should be on the roof. And where is this? Okay, if you click here, we have the air duct, and here we have all this information. Okay, so look at this. We have a drainage. When we have this water trap, remember that that means that we have a drainage, and we need a drainage because condensation happens in this, in all this. If you have this kind of system, you have a split system at home, for sure, well, if it's well done, the drainage connected to the drainage system, you don't see it. But there are a lot of places, including my home, in which we didn't do it well, and we need a pipe, and we have a planter with a nice plant that makes the most of the water that it's condensated from our sweat. Okay, so how beautiful! I'm feeding a plant with my sweat. Anyway, don't do that, and make sure that this drainage is connected to the drainage system of the house. We'll do that because we will deal with drainage in a couple of weeks. So probably we can go back to this and connect this to the drainage system. But okay, we have traps. When we have water traps, that means drainage. We have this electric. So this is the electric power. So if we are working with the wires, electric wires, this is the connection. And these closed loops are the inlet and outlet for the refrigerant fluids. Here, we don't have a difference between inlet and outlet. Why? Because this is a heat pump, and remember that we can reverse the cycle. So if we circulate the fluid in this direction, it heats up the air. But if we reverse the cycle and we circulate in the other direction, then it will cool down. So that's why in this kind of elements, we don't have supply and return or inlet and outlet, because we can reverse the cycle. But anyway, what we have to do is to connect this to the heat pump, and the heat pump has to be on the roof. So let's go back to the roof, and let's place the heat pump. And where is it? Well, you see that I have placed these heat pumps here, close to the split units that we have in the office spaces, but these are the new ones. Well, we have an issue with this, so if you want to see why we did this, you have to watch the other video. But here, I think it's easier because we have a shaft close to those split units. Okay, so we're going to use this shaft to go vertically from the roof to the first or the second floor. Okay, so we will have the heat pumps here, and then we will go to the shaft, and then we will connect each element to one of the heat pumps here. What is the heat pump? The heat pump is this. If you go to systems, mechanical equipment, we need this HC condenser, MEP counted, Mitsubishi, whatever. So this is the first element that we downloaded from this MEP file, and I think it's here. Okay, it's one of those. The condenser. Why are there two of them? Okay, so you see that here we have one tower, this one. And here we have two towers. The more towers, the more power the element has. So here we're going to use the one tower element. And here we have the 200, 250, 300. Let's select the smallest one, but this is because the building is small. Probably in bigger buildings, we need to select the two tower one with the biggest, with the greatest power. But let's do this, and let's make sure that we place it on level 30, which is the roof, and place it here. And now it's on level 30. Let's check that it's in the right position. Yes. So this is level 30. And let's analyze this. We have inlets and outlets in this direction. Okay, so those are, again, we don't have inlet and outlet, but this is where the pipes will be. This is the electricity. And anything else? No, in this one, we only have the pipes, and there's no difference between inlet and outlet. And then we have the electricity here, and we're not using the electricity. But I'm going to rotate it because we have to go in this direction, then we have to go to the shaft, and then we have to go in the other direction. Okay, so I think if we rotate it, it's better because I need to place three of them close to each other. So I'm going to rotate this here. I'm going to move it here, and I need three of them. So I'm going to copy this 1 and 2 times. Okay, so we have 1, 2, 3 towers, and each tower has a circuit. So we have to connect the first tower with the first one, the second to the second, and the third to the third split unit. So I'm going to draw pipe. Immediately I go to the shaft. Okay. Yes.
Mine doesn't look like that. Mine doesn't.
Okay, we are again. So now we have to connect this pipe to this element. It would have been better rotate. We'll be facing this way, but if this is a supply and this is the return. Anyway, we are dealing with pipes, and pipes are not difficult because they are quite small. We can have 1/2 inch or 1 inch, so it's not a big issue. But now we need to connect this. We have to draw this pipe, and we have to go to the shaft as soon as possible, like this, and then like this, and then this way. Now I draw another pipe and connect this. There you go. Okay. So what is important is that the vertical part of this pipe is in the shaft. Okay, the second draw pipe. Go this way. Let's make sure that we get into the shaft. Okay, going to move here. And now be careful with the intersections. So I do this, draw pipe here. Way. And there we go. Okay, so now we have to be careful with those intersections, but well, that works well so far. So what's next? We have to connect the second split unit to the second heat pump. Okay, so I'm not going to do it because I want to move on and explain other things. But at the end, remember that there will be a lot of pipes. So those pipes are very small, but we have to make sure that all those pipes are, the vertical elements are through the shaft. And we need 6 towers. Okay, so we can have 3 towers here and 3 towers there, because then we need to connect this to the first floor. So we can, I know what I would do, I think, is to select now these 3 towers, copy. I will place them here. And now we have 3 towers here, 3 towers there, and I can connect these 3 to the second floor and these 3 to the first floor ones. Okay, but at the end of this process, look at this, the roof is getting messy because then you have to do 4 towers for the office spaces, 4 towers for the first floor, 4 towers for the second floor. So we will end up having a lot of elements there. Okay. So I have already done one of them. You have to do it 6 times, but it's a question of spending a little time on it. But be careful, because when you have 6 different indoor elements connected to 6 different outdoor elements, be careful with intersections and with all these pipes there. So in mechanical equipment, we should have, oh, I don't have solar collectors yet, but I'm going to drag them. Here you see that we have 2 kind of solar collectors. So I'm going to drag this into my drawing. And now here we have the solar collectors. This is the roof solar collectors. If we have a tilted roof, I can use this. If we have a flat roof, I need a structure, and this is the solar collector with the structure. So we have 1, 2, and 3. I think this is the number of elements. Let's select the 3, and let's see. Oh, nice. Okay. Put it here, and let's try to find out how this works. Okay. First, the solar collector has to be on the roof. If you place a solar collector on the basement, on the first floor or on the second floor, you will fail the course. It's not because it has to be exposed to the sun. Second, we need the right orientation. So it's not placing the solar collector anywhere. We need the right orientation, and the right orientation, looking at this building, south is there. Okay, so they should face south. So this is not the right option because they are facing west. Okay, so I have to rotate this and they have to face south. And third, they should be in a place in which we don't have any intersection. So there is not an option placing the solar collectors here, just behind the cooling tower doesn't make any sense. Okay, so it has to be free of any other element. And finally, the fourth or the fifth requirement, I don't know, we have to place solar collectors close to the shaft. So if we have this shaft here, I think this is the right place for solar collectors because they are facing south. If we move this, they are facing south. Second, they are free from any other, so the cooling tower and the air handling unit will not cast shadows on the solar collectors. Okay, and third, they are close to this shaft, so we can go immediately. Because where does it come from? Where does this water come from? It comes from the mechanical room. In the mechanical room is where the boiler is, and here I have inserted a tank, but I will show you what I did with that tank. Okay, so again, we have solar collectors. Do we need 3? Do we need 6? Well, we have to calculate that. That depends on the consume of domestic hot water in this building. In this building, we don't have showers. And how many solar collectors we had for the TDS building? Only 2 or 3 panels, yes.
My solar collectors don't have very.
Okay, if we select this, now we need to understand, okay, so this is it. We have 3 solar collectors, and this is the inlet, and this is the outlet. You see that we have the inlet and the outlet, and what the hell is this? I don't know. But anyway, it doesn't have anything to do with water. Well, that's interesting because here we have 3 solar collectors connected as a series. You see that this is the inlet, that would be the outlet, and then this is connected to this inlet, and then this is the outlet, and this is connected to this inlet, and this is the total outlet. Well, this is basic stuff about circuits, and we can apply this for to water or any other fluid or even electricity. So there's a difference between a parallel connection and a series connection. If we have 1, 2, and 3 elements, each element has inlets. And outlet. Well, actually the other way around. This is the outlet and this is the inlet. Okay, so we have the inlet and the outlet, and all the elements are the same. So they can be connected as a series of elements. So if we just connect the inlet and the outlet, like this, and then we connect this one here. Okay, so that's the inlet. We heat up the water, then the water is heated up, then we go to this panel, the water is heated up more, the temperature here is hotter or warmer than here. So here we have the warmest temperature. So that's an option. Another option, it's the parallel connection. So the parallel connection, if we have inlets and outlets, I'm going to move it. Okay, so all the inlets will be connected to the same pipe. And then all the outlets will be connected to the same pipe. And I will do the touch line here. Okay, so you see the difference. So what is the best and what is the worst? What do you think? Any idea? Okay, so that actually matters. And if you're a plumber, you have to put a lot of thought into it because that affects how the system works. Imagine that this is the inlet. So this is the solar collector. So the water here, the inlet is cold, and we have to heat up this water. So imagine that each panel heats up the water like 10 Fahrenheit. Okay, so that depends on the specification of the panel, but let's try to understand how it works. So if the temperature of the water here is, let's say 60 Fahrenheit, at the end, we need the water, so the hot water that we consume in the shower or whatever is 140 Fahrenheit. Okay, so you have this configuration. Imagine that each panel heats up this, I said 10, let's say 20 Fahrenheit. So here it's 80 Fahrenheit. Then we move this. Here, there's another panel. So the temperature here will be 100 and 100. And finally, the water temperature here will be 120. Okay, if we need to heat up this to 140, because that comes from the water from the tank. Okay, so what we have here is a tank. So if we need the hot water supply to 140, what we need is and this is right. Okay, so this is it. We have the tank connected to the solar collectors, and the temperature has to be 140, and here it's only 120. So what do we need? We need another element, we need the boiler. And that boiler heats up this tank up to 140. With a supply and return. Okay, there's another question that you have to keep in mind. The hot water tends to go up. So the water here, can I do something shape field? Oh, we do have gradients. Okay, so look at this. In this tank, we will have the hot water here, and we will have the cold water there. So everything that comes from the solar collectors should be at the bottom of the tank. Okay, because if the water temperature here is 120, then the water tends to move up. But if we want to heat it up at 140, we have the boiler, and then we have this extra heating that we need. Okay, so this is how it works in this okay, so this configuration, this layout, I'm connecting inlets and outlets, and I have the first supply and the return. But I don't have supply and return in each panel. So with this layout, what I have is that if the water temperature here is 60, the return for this outlet will be 80. And that will happen with each panel. Have 60 and 80, and 60 and 80. So at the end, the water supply is 60, and the water return is 80. Okay, if we want to heat up water up to 140, I think this solution is better than this one. But if I want to do something else, now I don't know what I can do with this configuration. That's usually, oh, that's good, because what if, imagine that one of the panels, the second panel is broken. So if the second panel is broken, the whole system fails, because everything is connected. So if I remove this panel, if someone steals this panel, I stop having hot water. But if one of the panels disappears here, nothing happens, because we are heating up this water, and just we don't have this panel. Okay, it's fine. The system is not affected. Okay, so there. So sometimes we need connections like this, and sometimes we need connections like that. For heating up water in solar collectors, I would do this. And if I had more, then I would try to connect all of them in series to get the maximum temperature at the end of the circuit. Okay, so that's what I would do. In other options, I can do this because I need steady temperature, 60 and 80, and it doesn't matter how many panels I have. I have this 60 and 80 temperature. So if this is what I want, I would go for this layout. If I want to heat up water up to 140, probably I would do this. And if you add another one, if you add the fourth panel, and you would have 140, and you won't need the boiler. But this is what we are doing now. We are inserting a tank we are connecting this tank to the boiler, and we are connecting this tank to the solar collectors. And then finally, we will have the hot water supply here. So this is what we're going to do on the Revit file. Okay, so on the Revit file, you can find this heat storage. It's we have two kind of heat storage. We have the HC storage tank, MEP, whatever, and then the other one. This is a type catalog family. Systems, equipment, and here we have the storage tank. This one. And I want the other one. Like this. Okay, so they have to be on level -15. Okay, so I have two tanks here. Level -15 and the elevation 0. Okay, so just to understand the two kinds of tanks that we have here. We see that in this tank, there are a lot of connections. We have the cold water inlet, then we have a closed loop here, then we have another closed loop there, and another closed loop there. And finally, we have the water outlet, and this is red, so this is hot water. This is blue, so this is cold water. Okay, so we have a tank. We are using this water for the showers or for the sinks. We need hot water. If we use the hot water, the tank gets empty, and then we need to supply new water that it's cold. The water supply is cold. But here we have different loops. So that means that we can connect different elements to the same tank. With this one, we only have inlet and outlet. So with this tank, it means this is the cold water supply, this is the hot water, and this is the only closed loop that we have. So that means that in this kind of tank, we can only connect either the solar collectors or the boiler. So we can connect both elements at the same time. Probably this is cheaper than this, but I want flexibility. So I want this option. If the solar collectors are not providing me with the right temperature, I need to connect the boiler, and then I need to supply more energy to that tank so that I can get the 140 Fahrenheit. Okay, so out of these two tanks, you have to select the one with more inlets and outlets here. Okay. And well, what we found in the last section is that this tank, it works like this. So if we have this element here, we have the water supply to the boiler, and then here we have another water return. Okay, so what we found out, because here we only have two water supplies and we only have one water return. So what we did is to we connect this way. Okay, so the system decides, and here we need the three-way valve. So we need a triangle here. another triangle here. And another one here. Okay, so this is a three-way valve. So this element, the three-way valve, decides where here. Okay, so this element decides where the return comes from. So imagine we have a sensor, and the valve realizes that the water returning from the solar collectors, it's too low, and it can happen if this is, for example, 60, and this is 60, and this is 60. That happens because we don't have any sun. Okay, so we have if we have the same temperature of return that the same temperature of supply to the solar collectors, that means that we don't have any sun. So the system decides to block this circuit. Okay, I don't have any sun. Why do I have to get water from here? So I have to open the circuit to the boiler. If it's the other way around, if the temperature here is 140, and I don't know what kind of temperatures we have here, but if the temperature at the end of this solar collector circuit is the right temperature, is 140, they open this path and they close the connection to the boiler because we have the right temperature here. Okay, so this is what the three-way valve is doing. We're connecting, but we have only one inlet connection. We have two outlets. This is out, and this is out, but we have only one inlet connection. Okay, so that's the explanation of why we only have three elements here. Okay, so here we have inlet, here we have inlet, and we have only one outlet. Okay, so if we know this, we have to do this configuration. Okay, so we have to connect the boiler to one of the inlets, and then we have to connect the solar collectors to the other inlets, and then we have one return, and then we have a branch with a return. Well, it's complicated. Let's do it, and I think it will be easier to understand. So first, this out, and the solar collectors, if we have two inlets, and we do have two inlets here, this is inlet, and this is inlet, the water collectors have to be connected to the lowest inlet in this tank. So I'm going to draw a pipe from this one, but it's the lowest. It's not the one here. It's the second one. And if this has to be connected to the solar collectors, now we have to figure out how to do it, because we have to go through this shaft. So the shaft is getting busy with all this stuff we have here. Okay, but somehow we have to draw pipes. We have to keep going, and I will go to the shaft here. Be careful, because now we have a lot of things, but in the 3D view, okay, so there are no intersections. Okay, and now I have to connect this to the water collectors that we have on the top. So if this is inlet. We have to connect this to the outlet of the solar collector. So this is the solar collector. This is outlet. Okay, good. I'm going to draw pipe. This way. And now it doesn't allow me to do it. Here. Right. Okay, so now this pipe is floating and we have to move it down. So I'm going to change the mid elevation to 1. And now it's close to the floor and I have to go through the shaft. Okay, so here you go. I'm going to move it. Wait. So I'm going to move it here, and then eventually I will have to go this way. And I have to find the pipe that comes from this one, which is the tank here. I drag here, I drag this there, and now we have a vertical connection all the way down from the solar collectors, the tank. Okay, what I'm going to do, I'm going to hide things in view because it's a mess. So I'm going to hide in view all these elements. I'm going to hide in view all the ducts category and all the fittings, flex ducts, and the diffusers. Okay, so now it's a little clearer. So do you get this pipe from the solar collectors to the tank? No? Yes? Okay. I'm going to continue, and if you have any questions or you can't do it, let me know, and I'll be with you. Because this is the outlet, and now somehow I have to connect the inlet. Okay, so I have to do the same thing. I have to draw a pipe somewhere, and then I have to go in this direction. Okay, so I draw this pipe, and now I have to go in the same direction. Like this. Then I can change the elevation to 1 foot. And then I can go here and I can go to the shaft. Okay, so kind of, I come from the solar collectors. Probably I can change the elevation. It's better if I do this closer to the solar collector. Doesn't let me do it. And now I have to connect this to the outlet of the tank. Draw pipe, go in this direction. And I have to go to the shaft. Okay, so I have connected the outlet of this water tank to the inlet of these solar collectors, and the outlet of the solar collectors to the inlet of the water tank. Okay, so that should work. What I've just done here is this. We don't have all these, we don't have the boiler yet. We don't have these connections. We don't have this three-way valve. This is what I have done so far. I have 3 solar collectors. I have the inlet to the solar collectors, the outlet from the solar collectors, and then I connect this to the tank. The thing is that now I have to do this. Now I have to insert the same thing, or I have to connect the same thing with the boiler. So let's try. It's easier because now the boiler and the tank, they are very close to each other, and we don't have to do a mess. But we have the setback that this boiler now, it's already connected to what? It's already connected to the air handling unit. Okay, so the boiler is connected to the air handling unit, and it has to be connected to the water tank at the same time. So how can we do it? Well, first, we need to connect another inlet. So that's another inlet. This one. So I have to draw pipe. And let's ray for, okay, I'm going to hide in the or can I work with level 15? Yeah. So I'm working with level 15 only. And on level 15, that's the round duct. Okay, so this is not the, come on. Okay, so the problem here is that I have a lot of things. Level 15, I'm going to hide in view the duct. And now this is the default. Yeah, so this is the one that I have to connect to the tank inlet. So I want to go in this direction, then I draw pipe. And on this 3D view, I have to connect this and this. Will it work? No, it doesn't. In the top view, no, in level 15. Oh, I have connected the. You see, so this is what I don't want. I want to connect this one to this one, and I have connected the other one. Why? Probably I need to do this through the elevation, through the east elevation. I'm not. Okay, I want to make sure that you have this. Okay, what I have just done here, look at this. This is the cold water supply. This is the cold water supply, and this has to be from outside the building. Okay, so I move it outside the building because this is the city water supply, and at some point our building connects to the city water supply. There's a meter to find out how much water you consume and all that stuff. But for us, we have to connect the tank to something that it's out of the building, like this. And then we will do the hot water next week. Okay, so we will connect the hot water to all the sinks that are in the restroom, because we have the tank here and the restrooms are there. So we will have to do all these. Okay, so we'll have to connect this hot water to the sinks that are in the other part of the building. But now there's only one thing left. It's the connection between the return of the solar collectors and the return of the boiler. Okay, we need this option. So we need to connect something that comes from the solar collectors, something that comes from the boiler, just before the connection to the water tank. So how can we do it? I don't know yet. So let's see what we have. Okay, so this is the water supply. I'm going to delete, not to delete, to hide in view this element. Hide in view this, and hide in view all this. Okay, so if I have this hidden in view, I only have the water return. I don't have the water supply. And on the 3D view, I have to connect this one. Okay, so this is a supply to supply. And now I have to connect return, this one, that comes from the solar collectors to this return. Okay, so I think it's a good time to go to systems, to pipe fitting. You remember that we have the duct fitting, and duct fitting we have T's and elbows. in pipe fitting, we should have something similar. So we should have a T. Okay, so I connect this T, and if I connect it here, now I have a T, and I have a branch here. So from this element, I need a T, and then I have connected this here, and now I can draw a pipe in this direction. Probably move it here, and now on level 15, where is out? This is the T, and this is the connection. So I only have to drag it here. There you go. You see? Now I have connected the return of the boiler to the return of the solar collectors before entering the water tank. I thought it was going to be more difficult, but it isn't. So here we need to insert, well, we're not going to do it today because we don't have this family, but we need this three-way valve. It's not just a T, it's a three-way valve. We don't have this family here, but probably next week I will figure out how to insert here a three-way valve, because now this element has to control whether the water comes from the water collectors or it comes from the boiler before entering the water tank. Wow, so this is quite difficult stuff. It's not difficult because of the concept. It's difficult because we have a lot of elements here. So if we had done this at the beginning, without ducts, without the boiler, without the chiller, it would have been easier. But now, as we are adding elements, things are getting more complicated. But the complication is about finding a way to create the connections. If we understand what kind of connections we need, and this is what we have to understand, this is what we are doing. We're connecting a tank to a boiler, and we're connecting a tank to the solar collectors. And there's a point in which the water that comes from the boiler and the water that comes from the solar collectors, they are here. And then before doing this, we have to connect it to or before connecting to the tank, we need to create that T. And this is what we have done now. Okay, so what's next? I'm going to open an assignment, and by next week, I want this. I want the heat pumps, the split units inside each room, the solar collectors, the water tank, and then connections between the water tank and solar collectors, and between the boiler and the water tank.